Tonight I'm going to do pretty much similar to what I did last Saturday, which is basically 3D model up a control panel in AutoCAD. But this time, rather than use a pre-built panel, like a Schneider or an Eldon or something, I'm going to make the panel myself. Welcome in everyone, welcome in. Okay, so what view are we in here? Front view. Let's put that up on its back, off its back even. I've still not set up my 3D commands yet. Welcome in everyone. There we go, so there's the front of our panel. This is neither FreeCAD nor Fusion, mate. This is AutoCAD. Can't see my command line, and it's it's a bit of a nightmare. There we go. That should do it. There we go. Welcome in, everyone. Welcome in. This isn't AutoCAD Inventor, no, Peter. This is just well, it's AutoCAD Electrical, that's actually what it is, but you can do 3D modelling in it. That's top. That's front. There we go. Turn that background off because that's a bit annoying. Welcome in everyone. So there's the basis of what's going to be the panel, the enclosure itself. And now we need to just make... So this at the minute is just a big solid slab of material. What we need to do is do something called shell. I need to add my 3D tab so I can shell it. And what that's basically going to do is turn it from a big solid slab of material to a shell, so it has a hollow internal. Is AutoCAD Electrical a plugin of AutoCAD or standalone? It kind of is a plugin, because you do need to download like the base AutoCAD for it to work, but it's sort of classed as its own software. It has its own like executable, but I think it still uses the generic AutoCAD in the background, mate. Right, so we've shelled, did we shell it? We haven't shelled it yet. So what I'm going to do is click that, and it's going to ask me what's the offset distance, and most enclosures that I work with are 2mm. So now this has gone from a big solid slab of material to now 2mm the whole way around. It's got a big hollow internal. And I want to go into front view now. We're gonna draw a square, a rectangle even. And where is my rectangle? Is it front or back? It's at the back. So bring it forward 400mm. That is 400, I think. No, that was 4,000. Never mind. Right. Why not build highly advanced robo? Yeah, no thanks, mate. I'll let you do that if you want. You do you, buddy. That's not for me. Is this your business? I guess it is. This is what I do at work. As a design engineer, I 3D model up control panels. I do the schematic side as well. But yeah, this is. I don't own my own business. I am fully employed, like full time. So I'm putting a rectangle on the front because what we're going to do is we're now going to push through that material to get rid of that 2mm. You'll see when I do it. So press pause. Welcome in everyone. I'd appreciate anyone who likes, shares the live, all that good stuff. We've just started tonight. I was on a little bit late. I went to a fireworks show. That is not picking that up. So I want that to be right sat on the face. So now if I press pull, it picks up that. Try that again. It's a bit of a nightmare not being able to see the command line. So basically what we started with was a big slab of material. We then shelled it to 2 millimeters thick, so it was hollow internal. Now we've just pushed out the front of the front face of the enclosure, because we're obviously going to need a door and stuff. Do you do the wiring side or just the PLC and sketches? I don't do any wiring, mate. No. So at work, I mainly just stick to the design programming side. The wiring, we have a bunch of wiremen on the shop floor to do the wiring of the panels and actually put them together. So I just tend to do the design side and then the programming. Yeah. Welcome in, everyone. Welcome in. Really appreciate everyone liking the live. Thank you. Okay, so there is basically the basis of the enclosure. What I tend to do is I will just slice off the back portion, because if I want to do any work on the inside of the front, I can't see it. I can't get to it. I could put it in X-ray, but it's just easier if I just slice off the back section. Ruby, thank you for the heart puffs. Really, really appreciate that. Thank you. This is 2 meters high. 2 meters, mate. Yeah. It'll have a 100mm plinth when we're done, so it will be 2.1. Have I missed some followers? I feel like I have. There's a lot going on. Welcome in, everyone. Welcome in. I'm lost in the comments already. What are the notable differences between this and SolidWorks? SolidWorks is a package that's made for 3D modeling. This package is more so AutoCAD itself is, when it was first created, it was all 2D. They then brought in a 3D element to it, and it does it okay. It does it's reasonable enough. But SolidWorks, I believe, was built from the ground up to be 3D, so it does it very, very well. Slice. But you can do plenty of 3D stuff in AutoCAD, and it'll work just as well. So let me just hide that back section now. So I've just sliced into it. We will join it back together again at the end. It's just to make life easier. So what I want to do is I want to move these faces. So at the minute we've got a 400 deep panel, but obviously there's a door as well. So what we'll do is we'll make it 380 deep, maybe make the door 20mm deep. Yeah, that's what I'm thinking at the moment. What I'm looking for though is the command to move faces. Normally I have a bar all down the side with all the buttons that I need. I don't have that at the moment. Move faces, that's the one I'm looking for. You guys can see that okay? Yeah, I think so. Let me just push that in 20mm. So now I've got a 380 deep panel. And what we're going to do is going to build a door. And to build a door, I'm going to make another rectangle, the full size of the enclosure. I can now hide that enclosure. So I'm just left with a rectangle. I'm going to then press pull that rectangle to basically extrude it, make it a solid mass, and we'll make that 20mm. Then I'm going to shell it. So I'm going to turn that solid mass of a door into a hollow shell. This is my job as well. Smart Plant PDMS. Oh, nice, Lewis. Oh, thank you for joining, buddy. Hopefully I can show you something, and if not, maybe you can give me some tips as well. Right, so that's now a hollow shell of a door, I believe. We're going to turn it back round. Try and grab onto our rectangle. I'm going to offset that by, let's say, just 2mm. Yeah, I just want 2mm offset. So now you can see I've got this, hopefully you can see that. I've got a solid mass, which is actually hollow now. Then I've got a little rectangle here. I'm going to do press pull. And I'm going to press that in by 5mm. Did that work? It didn't. My shell, oh no, it did work. There we go. So you can see now I've got what's starting to look like a door. Hopefully you can see that. Let me bring back my enclosure. So now I can kind of show you this pretend there's a hinge there. And if I open that 40, you can kind of see it's starting to look like an enclosure now. Yeah. So there's the base. I'll undo that just so we've not got a half open door. There we go. Yeah, it's AutoCAD, buddy. It's AutoCAD. Do you have any suggestions how to use logic controllers with the thermal label printers? Because you sell them. Not really, mate. Nothing comes to mind at the minute. Ruben, thank you for the follow. Really appreciate that. David, thank you for the follow as well. Yeah, I don't know what you would... the thermal printers, I can't really think of much. What can you do with them? You know, I'm assuming they've got their own software and stuff, have they? How do you get AutoCAD at home, though? AutoCAD's based on... it's account-based these days. So as long as you've got an account that has the license, you can download it anywhere. As long as only one account, you know, the account's only being used at one time. So I just use my work account, yeah. Oh, they have a scripting language. Oh, okay. Why would you model an AutoCAD instead of Inventor? Because Inventor costs a whole bucket load more money, mate. Yeah, Inventor's very expensive. And when you're doing electrical schematics and stuff, Inventor doesn't do that. So you use AutoCAD Electrical, and then you use the 3D component of that. All for the one price. 911 Recreation. I'm not sure what you're talking about there, Mike. Okay, so we've got our enclosure. Let me make that door the same colour as the rest of the panel. It looks a bit off. RAL 7035 is what we typically use in the UK. Okay, so I'm just going to shift that across by 400. Because it's kind of... yeah, that's better. It was pivoting like on the edge of the panel rather than in the centre when I'm rotating, so it was a bit of a nightmare. Sure, but CAD is worse for clashes, etc. Yeah, it can be. There's no like clever functions or anything like that you would get with Inventor. Inventor is definitely better, mate. No doubt about it. If you had the choice, yeah, definitely use Inventor or SolidWorks. But you know, the amount of money you would be paying for AutoCAD Electrical and AutoCAD Inventor would be wild. Followed, so you can teach me, please. 3LY, yeah, that's kind of what I'm trying to do, buddy. I come on lives most weekends now and just try and show off some stuff, try and teach people new things. So thank you for following along, buddy. Yeah, so just simply modeling, then I can feel like, yeah, that's it. Yeah, I don't do anything crazy. I'm not, you know, I don't model up big machinery or anything like that. It's just control panels, and AutoCAD's plenty good for that. What's the program called? This is AutoCAD, buddy. Do you have to design metal enclosures all the time? Aren't they off the shelves? Not often. So I do have to definitely design enclosures because some of our customers like custom built enclosures. They don't like the off the shelf ones. But yeah, most of the time I use like Eldon or Schneider, maybe sometimes Rittel. Nimi, thank you for the follow, mate. Really appreciate that. AutoCAD is free for one user. No. The company pays for the account. So, you know, as part of work, I use this software. But because it's account based, I can just log into my account from home and use the software. It's free for students. Yeah, if you've got a student email address, you can get it for free. For 3 years, I think, or it used to be 3 years. What's the shortcut? What's the key shortcut for pan? Middle mouse button, mate. If I hold in my middle mouse button, I'm just panning around. If I want to rotate, it's shift and middle mouse button. And if I'm obviously zooming is just the middle mouse, you know, scrolling it. Yeah, start with FreeCAD or SketchUp if you don't want to pay. And also SkyCAD, I believe SkyCAD's free, which is supposed to be pretty good. Anyway, so I have now the basics of an enclosure. I probably don't need to see inside it again, I would think. I'll just leave that slice there for now. Right, I'll hide my door. We'll just work on the internals now. So what I want is, let me just center that. Don't know why, but the rotation went weird again. So now we need a mounting plate. So inside of a control panel, you will always have the external enclosure, the steel metalwork which forms the enclosure, but then you will have a galvanized steel mounting plate inside, or sometimes it might be painted, and that's where all your components mount to. I'm sure they're changing the student option in March. It gets exploited too much. You're probably right. You are probably right. I used to use the student version when I was a student, and then when I stopped, when I finished my qualifications and stuff, I could still use it for a good while, like another 2 or 3 years. So I imagine it probably does get you abused a little bit. So if you haven't got it yet and you are a student, probably is a good time now to get it, because I imagine they probably won't take it off you if you've already got it, but they probably won't allow you to do it anymore. So let's make this 20mm offset. Did you go live tonight, the engineer? I seen you were gonna go live. I've been out all night, so I didn't manage to catch it. It was a fireworks show. Press pull that, and I just want that to be, I think normally about 1.5mm. Let's just hide that, get rid of our rectangle, bring that back again. Thank you, user 422. Appreciate you letting people know. Bring that forward by 3mm. So I'll just change the color in that so you can see it a bit better. Thank you, Kay, for letting people know. I imagine if you do things like this a lot, you could do dynamic blocks. Not entirely sure what you mean by that, buddy. We did some projects in the past using dynamic blocks, saved a ton of time. Yeah, I mean, when you do it a lot, you kind of build up this library of enclosures and stuff that you use all the time. So more often than not, you don't have to remodel it. But when you're doing a custom enclosure, usually there's a reason for that, and they're a funny size or they're a funny shape. So you probably do have to redo it every time. Michael, thank you for the follow, mate. Really appreciate that. Okay, so we've got the enclosure, we've got the mounting plate. We need a plinth. We need to put some handles and stuff on the door. I probably don't need that slice anymore, so I'll do a union and just join them two together now. There we are. There's the back of the panel, the front and the door. If I just rotate that door slightly, let's say 120mm, you can see you've kind of got the beginnings of an enclosure there. I tend not to go too crazy with it. Like, I don't start filleting the edges and stuff. In reality, you know, they're not perfect points in the corners and stuff. They're all kind of rounded. I don't go to that sort of level of detail on the models, because it just, you know, takes up time and it's kind of unnecessary. It's a visual thing. Rails. Oh yeah, I'll get to all that. I'll get to the internals fairly soon, Lee. Yeah. Appreciate everyone liking and sharing and all that good stuff. Yeah, really appreciate it. Okay, so on the bottom we're going to have our plinth. So I'm just, you'll see the basically how I do this is I just make everything into rectangles and then just extrude it, shell it if I need to. Press pull. I'm going to bring that down 100mm. There we go. There's the beginning of our plinth. I'm going to now shell that, so it's, at the minute it's just a solid slab. I'm going to shell it so it's 2mm. What's it asking me for there? Remove faces. I don't want to remove faces. Enter the shell distance 2. I think that should do it. Right, where's the rectangle? Because we'll need that back again. I need to offset that now by, let's say, 40mm, I'd say. So inside And we'll just punch through that. I'll just try and make sure you guys can see. Oh, I seem to have lost a face. Yeah, I didn't mean to do that. At some point I've lost a face. I'll just shell it again. 1 second. There we go. And then we'll go back and offset that again by 40 mil. Oh, in fact, I need to hide it first. Offset 40. Bring that inside. Bring everything back. Hide them two. Hide that. Press pull. There we go. That's better. I'm a games design uni student, just started. Can you give honest advice for learning Blender? Struggling. I don't use Blender, buddy. This is AutoCAD, this isn't Blender. I have tried Blender and it's very, very different to AutoCAD, so it was quite a steep learning curve for me. I'd say the only thing I can say is keep practicing, keep watching stuff on YouTube. There's plenty of tutorials on there. Yeah, keep practicing. I guess that's the only thing I could say. Let's make this black, RAL 9004, I think. Yeah, that looks good to me. So there we go, we've started to get it looking a bit more like an enclosure. Okay, so let me close this properties down for now. I want to put a handle on the door. One thing before I do that. Let's pull that over here. I want to get the dimensions for that, the handle cutouts. I can never remember them. It's like it's a square and a circle, and you just have to start chopping it out. 1 second, let me just find it, and I'll show you what I'm talking about. Latches and locks. Tend to use all MCA locks and latches and stuff like that. MCA's a company that do just fucking everything when it comes to locking mechanisms, hinges and that sort of thing. But they have a specific type of cutout that they want, and I can never remember what it is. This one. Come on. Right, cutout. Where's the cutout? Lars, thank you for the follow, mate. Really appreciate that. Right, here it is. Here it is. I'll take a quick screen grab of that. So I don't know if anyone's ever seen this before. Let me just zoom in. This is what I'm talking about. So most enclosures that I work with, almost all of them I would say, use MCA equipment. MCA like handles, MCA hinges, that sort of thing. And that's the cutout for the handle. It's a 22.5mm circle with a 20.1mm square. I'll show you it. Let me just pull that over here, and we'll put it together and then cut it out the panel. So put this into diameter 22.5, and then we want a square which is 20.1 by 20.1, and then I just shove that in the center. And I want to keep the rounded corners but bin off the rounded sides, if that makes sense. So cut that, cut that, cut that, cut that, cut them two, but then keep the straight sides. So that ends up being the cutout for those MCA handles. So now that I've got the cutout, I can put that on my door. Let's make it hinged on the right hand side, I would say. But before I do that, I'll just hide everything else because it tends to get in the way. So I'm just left with the door and the cutout itself. Bring that roughly in the center. So object snap midpoint. Put that in the center there. push it in 50mm, and do a press pull on that. So there we go. We now have a cutout for the handle. E-Plan 2025. This is AutoCAD, mate. This isn't E-Plan. Looks like a watch. It does a little bit, yeah, you're right. So yeah, there's a handle, and I can import a handle in. Let me just press the import button. Why is it not come up with the file? Oh, there we go. And I should have somewhere. PB Singh, thank you for the follow, mate. Really appreciate that. I should have some MCA parts already, I think. MCA, drawings, locks. Quarter turn with insert, that sounds about right. I'd probably normally put a handle on a panel, like a door this size, but just for now. Where's that coming? There we go. So if I line up the center of this here, I can just smash that into, can you guys see that okay? Yeah. Center of there. So you probably wouldn't have a lock like that. You'd probably have a handle on a door of this size. It'd probably be a 3-point handle, but I don't have a model of that, and I'm not going to bother downloading it. So just for now, that's going to be our lock, and you would put a MCA key in there. So it's like you need a tool to open this door. It's not like a security lock, so you can't put padlocks on it or anything like that, but it does require a tool. Just anyone can't just walk up to this door and open it. I bought the book by Frank Petrozello. What other books did you recommend? Nice, Peter. Yeah, that's a good book. The other ones were by William Bolton. I think it was just called PLC Programming or something like that. Also, a book by a guy called Liam B. He has a good book on Siemens. So Frank Petrozello, I think his focus is on Rockwell PLCs, but in general, it's a good book anyway. Liam B focuses on Siemens, and William Bolton, it kind of does the book for all different types actually. Red key, yeah. If you buy an Eldon panel, they come with a red key now, yeah. They never used to be. They used to be black, I believe. The software is called AutoCAD, buddy. Yeah. So, okay, there's our door. Let's bring everything back. There's the full enclosure itself with the plinth. It's a basic plinth, and we'd probably actually as well, while we're on with it, we'll do a cutout in the bottom of the enclosure and put an aluminium gland plate in. If you have a load of cables that take any sort of current, I mean, if it's less than 100 amp, you probably don't even have to bother. But I tend to, as a matter of course anyway, put an aluminium gland plate in. If it's less than 100 amps, you probably get away with a steel one. It's not a problem. But you're trying to limit the eddy currents between the cables on your enclosure, coming into your enclosure. What's a plinth for the purpose of a plinth? It's like a stand for the panel to sit on, but it also aids with cabling up and that sort of thing. It's unusual to have it as a solid block like this, but I definitely have done it plenty of times. The better ones are the ones that have removable faces and stuff like that, so you can take the front off, or the sides as well. But it's kind of like a stand, and it also lifts your panel up off the floor, so if there was a leak in the room or anything like that, 100 mil, that's a lot of liquid that room would have to hold before it got to your panel. Okay, so let's get rid of the panel again, and that this time. I seem to have a few rectangles there. I think that's the one I want. Let's bring that in by, I don't know, say 60 mil. Let's see how that looks. That doesn't look too bad. Okay, so I can delete that one now. I can delete that off. So we should just be left with the enclosure with a rectangle in the middle. Let's have a look. Yep. So if I do a press pull now, that should just punch straight through. It does. And then using that same rectangle that I had, I can make that 20mm wider, delete the middle one, and press pull that to extrude it and make an aluminium gland plate, which could be 3mm thick. If at any point any of this is going over anyone's head, feel free to let me know and I'll explain what I'm doing. I feel like I'm going maybe a bit quick for anyone who's not used to this sort of thing. So yeah, there's our 3mm aluminium gland plate. Let's give that a slightly different colour. I tend to just make them look slightly silverish. What software is this? What happened to Fusion 360? I've never shown Fusion 360 because I haven't got it. This is AutoCAD. AutoCAD Electrical, actually. How is that fixed? You would put holes in. I mean, I wasn't going to go into that level of detail, but we can since you've asked. Let's do some 6mm holes. And they'd probably be 6.5. In fact, I'll just make it 6.5mm, just for the sake of it. So then you could use an M6. Oh, that didn't quite work how I wanted it to. Then you can use an M6 bolt, 6.5. I'll put it in one corner. I'll take it in 10mm. Take it up 10mm. In fact, I'll just isolate this as well. So we're just looking at this to try and keep the focus on the aluminium gland plate itself, and we could copy that. In fact we won't, we'll mirror it. We'll find the center point and we're just going to mirror it like that, and then we're going to use them two, and hopefully you can see this all at once. Where's my center point? There it is. I'll pull it that way, and we're mirroring it again. So now I have them in all four corners. And that'd probably be okay, to be fair, but I'll put some in the center as well. So going from the center of this circle, object track to the center of the gland plate. Thing is that when you're doing 3D modeling, you don't want to go into too crazy detail, as into like nuts and bolts and that sort of thing, because it all just slows down your model. You want to keep it nice and light. You know, it's really not critical what type of hardware that you use to fix stuff down, but I'll show it anyway. So now I'm just punching the holes through the material. Oh, I didn't mean to do that. There we go. And that's not picking up. Why is that not? There we go. Press pull. There we go. So now there's some holes there, and obviously there would be equally holes in the enclosure as well. Fusion 360 is free for personal use. It is, mate, it is, but as far as I'm aware, Fusion's really just meant for small scale parts and stuff like that, rather than like an assembly, like a control panel. Is this Revit? It's not, mate, it's AutoCAD Electrical. So yeah, we would then, you know, I'd chuck in some M6 bolts, nuts on the other side underneath, through the enclosure. So that's how it would be fixed down. Okay, so one thing I haven't done, which I do tend to like doing, is group the door handle and the door itself, so that whenever I hide the door, the handle now goes with it. Yeah. And I would also group the enclosure with the gland plate. So if I ever hid the enclosure itself, the gland plate goes with it, as does the plinth. I don't need any of those circles and stuff anymore. So then I'm just left with a mounting plate. And then for the mounting plate itself, we can start adding trunking, DIN rail, and components. Don't want the right hand side. And actually as well, you would, in reality, this mounting plate would have return folds on it, so I will show them as well. I will do them. because the length for this piece of metal, it's only 1.5 mm galvanized steel, and if you had no return folds on any of that, it just bend and twist and all sorts. Never used AutoCAD before. What's the difference between electrical and original? So original, you can do everything that I'm going to show you today. The normal AutoCAD has all the 3D in it. The electrical side isn't what I'm going to show today, but that is for like for doing schematics and stuff like that. So I think last Sunday I did a live where I went through putting some schematics together using the electrical components, and it's all like pre-built blocks. They have intelligence behind them. You're able to match contacts to coils and stuff like that, and it pre-fills in all the information. Yeah, so what you're seeing now, it doesn't matter that it's AutoCAD electrical that I'm doing it in. You can do all this with normal AutoCAD. The only CAD that you can't do this with, the only AutoCAD you can't version, is AutoCAD LT, which is AutoCAD Lite. I think that's what it stands for anyway. And that's just 2D only. I appreciate that, PB. Thank you, mate. Excuse me. Right, so let's go behind this mounting plate. And same story again. I just use rectangles for almost everything. Let's make that, I'm going to say 800 wide, but it'll be a bit less than that, but you'll see what I mean in a minute. So 800 wide by 2, in fact it was 1.5 mm. So it obviously goes over a bit, but I can just pull that back in. I don't know the exact dimensions that I've made this mounting plate. Let's pull that in by 3 mm and pull the other side in by 3 mm. And then if I just go in like a slightly isometric view, you'll be able to see what I'm doing here. It's quite difficult to see because it's white on white. That actually wants to be right up against that. There we go. So I'm going to press pull that now. And I pull it out. And I only want this to be maybe, say 5 mm. So what I've just done there is created a return fold. So you can see on there, it's hard to show it because it's so light. But the metalwork folds back on itself, and I could fillet it and all that and make it nice, smooth, rounded folds, but you don't have to. When you start filleting stuff, the AutoCAD has to store more information in the model, and it can, if you've got a big panel, it can really slow down your model. So we're going to do that for basically everything. So let me just go back because I did delete my rectangle. Right, it's back. So that rectangle wants to be down at the bottom now. So we're going to fold every edge of this mounting plate, because without that fold you just don't have any strength in the metalwork at all. Press pull. Again, you can't really see it too well because it's like really white. Sorry, just got here. Sorry, hang on a minute. Oh, let me catch up. Isn't AutoCAD more architecture? No. AutoCAD is used for many different fields and stuff like that. So it's used for piping. It's used for architecture. Obviously, it's used for. It's got so many uses. It's a very generic software. You can use it for almost anything. The engineer, thank you for sharing the live, buddy. Really appreciate that. If anyone's watching this and they're enjoying it, please hold in your screen. It should bring up a little box, and you'll see on the left there it says repost. I'd really appreciate it if you could do that. What software do you do the wiring schematic in? Yeah, it's AutoCAD electrical, buddy. Yeah, so that's what this software is. It's just I'm using the 3D component of the software rather than doing the schematic side. Let's pull that up by 3 mm. So that's about right there. Let's look at the. So it was much shorter. Let me just make this mounting plate dark for a second, because I find it's hard for me to see, and if it's hard for me to see, it's definitely hard for you to see. So let's make it a much darker colour for now. We'll put it back again afterwards. It's much better to see now, isn't it? Why am I seeing CAD modelling at midnight while on the loo? It's not midnight already, is it? I started late. Normally I come on about 8, half 8 maybe on a Saturday, UK time. But I was at a fireworks show tonight and we didn't get back till quite late. So I didn't come on till like maybe 9:15 or something. Marius, welcome back, buddy. How are you tonight? Make sure you wash your hands. Okay, so let's press pull that. There's our return fold for this edge. I want that. I think I made them 5mm. Yeah, I did. And then we're going to do the same for the other edge. So these return folds that I'm doing, I mean, they're not necessary for the model. You know, any metalwork company, you know, who knows what they're doing would know to put return folds anyway. Good to hear, buddy. But I'll show it. I'll just show it and I can explain why. If you had, I don't know if you've ever had like a large piece of thin material, whether it be plastic or whatever. It's very bendy, it's very twisty. There's no strength to it whatsoever. If you put return folds on all the edges, you get a lot more strength out of it. It's not easy for that material to bend or anything. Did I miss something there, Katie? Peter, thank you, mate. I really appreciate that. I do apologise. I missed that. Thank you for the heart me. Okay. So there's all our return folds. Like I said, oh, I've deleted everything there. Didn't mean to do that. Oh. There we go. And you probably wouldn't have that square on the corner either. That would be gone. So just for completeness. Oh, I've lost it. There we go. I do apologise. Let's put that there for a second. Push that up that side. Press pull. Push that through. So that material wouldn't be there, that square. It wouldn't be possible to have that material there to do to be able to do the return folds. Press pull. So obviously I'm going into a lot of detail here, but like I say, you wouldn't need to do this in reality. There we go. So go to front view now. So there's our mounting plate. I'll make it white again. Now we're finished with that. There we go. And if I unhide everything, there we go. We've got a full enclosure now. Plinth, door, the enclosure itself, aluminium glam plate, and a... Does that come through the back? It probably does. That would sit proud on some bolts or something. So bring that forward 5mm. Okay, so now we've got an enclosure. Let's just hide all that. We're just going to focus on the mounting plate now and putting components on. We'll start off doing trunking, layout, where you're going to be putting stuff, you know, how it's going to look. Is this a Rittel cabinet? This is a logical controls cabinet. I've put this together myself just during this stream. I was a press brake operator for 4 years and then ended up being an engineer for Safan. Sorry, I just joined. What are you designing? I'm just doing a control panel, mate. Yeah, but this time I started by designing the enclosure itself. Cheers, the engineer. What are you using to model? This is AutoCAD. AutoCAD electrical, but you can do it in just generic AutoCAD. Right, okay, so I explained this last week when I did the model last week, but I'll explain it again just for anyone who didn't see that or anyone who's new here. For trunking, you can put in the proper model for trunking and it'll all look really nice, really good. But the problem is that with that is it's very heavy. There's too much detail for trunking. You know, trunking's trunking. There's no need to make it any more detailed than the width and the height of it. So what I tend to do is, as you've just you know, been watching this whole time, make a rectangle, and I'll make this 60 by 100 trunking, and then I'll just extrude it so it looks like a box. You know, it just looks like a big rectangle. I could, and I'll show you what I mean by this. I could bring in a proper part for the trunking, but it's just too much detail. It's unnecessary. It just slows down your model, and there's just no need for it. So let me find it. Where do I store it? Here. Trunking. Bring that in. And where is it? So that's the kind of trunking I use. It's basically called finger trunking, I believe. You know, it's has all these fingers on the side that you can break out and snap off. It also has a lid to it. But if you were to use, you know, model up your whole entire panel just using this stuff, the amount of detail that's gone into this, the amount of, you know, arcs and faces and edges and stuff, it'll just slow down your model. So you don't need to go to that level of detail. I could if I wanted to, and it would look really nice, but it'd be a slow model. So instead, I just go with the rectangles. Because to be fair, you don't need any real detail in your trunking whatsoever. I'll change the colour of this trunking. The stuff that we use is ABB, and it's a bit darker. Let's go for like that sort of colour. Okay, let's rotate that. $90. There we go. Get rid of that rectangle. So there's one side. I'll bring it right the way down. I need to sort the buttons out on my mouse so I don't have to keep typing the command every time. Let's bring that up by 60 because we're going to have a row of trunking at the bottom. So minus 60 on that and minus 60 on the top. Copy that all the way across to over here. Line it up like so. ABB trunking is horrible. I don't mind it. I've never had a problem with it. Yeah. Does the job. What stuff do you use, Daniel? When you're going to do a tutorial about RS485 RTU with 2 devices, that is coming soon, mate. I promise you. I've been saying for ages and ages I'm going to do a Modbus video, all about Modbus and that sort of thing. Today I spent some time on my Siemens S7 1200, got that talking to my HMI, which talks to all my PLCs that I've got. I've got like a bit of a system going on now, and that's doing that over Modbus. It is Modbus TCP, so not exactly RTU, but they're very similar. Marcin, thank you for the follow, mate. Really appreciate that. Right, okay, let me just pull that out a second. Make it, let's pull it out 150. Press pull. Oh, press the wrong button. And take that to the inside diameter, the inside dimensions of that trunking. 150 back in. And there we go. So now I can just copy that down. The sizes of each section, I guess, would depend on what you fit in. I don't really know what I'm fitting yet. I'm just going to keep chucking them in equal distance apart. And we'll leave the bottom open. So, do we leave the bottom open? It's a bottom entry panel. Let's do one more. Let's leave it there. Let's bring them back up. Hopefully this is making sense. If not, just shout out any questions you've got. Thank you, Katie. Yeah, if everyone can just tap their screen, give me some likes, and and share it as well if you feel like it. I'd really appreciate that. I would like a Mitsubishi RTU tutorial with 2 devices. I could not manage to work properly. Ah, you were... Yes, I remember you were having issues with that. The problem is, I don't have... I think I've only got... Because you were using GXWorks too. I'll have to have a look. I'll have to see if I've got the right kit. I'm not sure if I have or not. If not, it'll have to be using GXWorks 3 with a Mitsubishi FX5U. Really appreciate the likes, guys. Thank you for that. What CAD software is this? I think I might have already answered that, but it's AutoCAD. Can't remember what it's called. We used to use ABB and MCG, and they are too firm and solid. Ah, I see. Yeah, I mean, I can't say I've ever had any issue with it, to be fair, but then again, I'm not the guy that works with it, so I design it, and then I come and program and test. I don't actually do the building or the cutting or anything like that, so yeah, I'm maybe not the right guy to say it's really good or anything like that. Right, so there we go. We've got our sections. I've no idea what we're going to put in yet, but first things first, we need some DIN rail. Is it easy? Yeah, I'll bring it in. The DIN rail part I've got isn't great. I do need to explode it and change the colour of it, because I think it comes in as orange. I do need to find it first though. Where have I saved it? DIN rail. Here we go. Has it come in as orange? I think it probably will. Where is it? There it is. Hiding. And it's only small as well, so I have to do a bit of messing around to get it to work. I want 3D rotate. I want to bring it 90 degrees that way and 90 degrees that way. In fact, 180 degrees that way. Right, okay, so there's the DIN rail. Let me explode it so I can mess with it a little bit. Change the colour of it to a lightish grey. That doesn't look too bad. I do believe that I need to do something like that to make the... See, I normally just copy and paste from my previous jobs. Do something like that to make it the right size. Okay. Let's add a few of them. In fact, let's union that first. Why is this telling me inactivity? There we go. Right, we're back. Yes, FX2 works too. I'm not sure if I've got enough parts for that. I'll have to have a look, Marius, but there's definitely Modbus videos coming. Currently trying to make a rig to test control circuits. Gifted some stuff by work. Nice, Daniel. Yeah, if you can get stuff for free, that's you're onto a winner there. Taking inspiration from yours. I don't know if that's a good idea, buddy. Mine are pretty rubbish, but yeah. Keep it simple, I would say. Make it work for you. Doesn't matter, you know, if someone else wouldn't do it the same way. If it works for you, that's the best thing you can do. My little test rigs, they work for me because I didn't want anything massive, and I didn't want to lug it about. I wanted to be able to move it, keep it mobile, keep it simple. If I ever had to change it, the wiring's all there. I don't have to hide it or anything like that behind trunking. Yeah, mine work for me. That gap's too big. Oh, but yeah, if you got some stuff from work, you're winning because it's expensive. Union, can't spell. There we go. Right, let's get it on the back of the mounting plate. And we want to put it exactly in the center, so I'll draw a line from there to there. So I have a line there, hopefully you can see that. And what I'm going to do is grab the center of the DIN rail, which is there. Point filter only on the y-axis and send it to the midpoint of that line. That's typically how I do it. And now that's perfectly in the center. Bring it along a little bit, and then I can just copy them. And in fact, let me slice it first, because it's a pain. The way that it is at the minute, it's a pain to copy. So let me just do a slice. On a slice, in fact, I need to do a line first. Do a line. Do a slice. Excuse me. Top to bottom, slice that end off. There we go. That'll be better now for copying, because I'll be able to get it exactly the right dimensions each time I copy it. Have you ever used Ace? I haven't, mate. No, I'm not even entirely sure what they are. Yeah, I've never even heard of them. Are they an old type of PLC, or are they like a current thing, or what? What are we making? We're just designing a control panel, mate, in AutoCAD. So this is just the mounting plate. I've hidden the actual enclosure itself, but we're starting to put DIN rail down. We've done our trunking. We've built the mounting plate. We've put the return folds in. So yeah, we're just at the moment putting the DIN rail on. I'm just getting it to the right length, get it all the right color as well. Excuse me, doing too much talking. We started late tonight. Normally I start about 8 o'clock, 8:30, something like that. But I went to a fireworks show, so I started late tonight. We didn't get back till quite late. Let's put that 10mm in. Find a good point to slice, and we're just going to slice it there in the middle. So put a line across there, do a slice on that. I want it vertical, there we go. And now I can do a union to join them all together, because at the minute they're all individual parts. I think you can see that okay, can't you? There we go. Check the colour again, because I think every time you do a slice it loses its colour. It's quite annoying. That colour there. Alright, there's our DIN rail. Let's put it perfectly in the centre. Line up X axis. There we go. Agree with you there, the engineer. Schneider M221 PLCs are really... They're very capable for the price. They don't cost a lot, but they can do an awful lot. They're a good little PLC. Cody, thank you for the follow, mate. I really appreciate that. Right, so I'm just putting lines in so I can line up all these DIN rails perfectly in the center of each section. So I'm going to copy, I'm going to pick the midpoint, I'm going to do a point filter on the y-axis, which is the vertical axis, and then I'm just going to find the midpoint of each line. In fact, I need to do that first, and then do that. No, that didn't work. I need to do it each time. So there, point filter Y in the midpoint. There we go. No, I did that wrong again. I want the Y point filter. I'm trying to go too fast. And there we go. So now I've got DIN rail in each section. Snord, thank you for the follow, mate. I really appreciate that. New type micro PLC from France. Ah, okay. Yeah, I've never heard of an Ace. Yeah. Is Ace the manufacturer, or is that the model? Is this ePlan Panel Pro? It isn't, mate. No, this is AutoCAD. How long did it take you to learn all this? I've got a 3D printer, but I don't have patience to learn. 3D modeling is relatively new for me. I only probably picked it up maybe 3 or 4 years ago, and I would say for me to get pretty proficient at it, it was maybe like 3 or 4 months, maybe 6 months, but using it every single day. So it does take a while. at least, you know, it doesn't take long for you to pick up the basics, but for you to get actually good at it and be relatively quick does take a little while, yeah. Ace is the manufacturer. Oh, okay, buddy. I've not heard of them. I'll keep an eye out. Have you used them before then? Are they any good? Jordan, thank you for the follow, mate. Really appreciate that. Okay, so there's... Let's... For anyone new who's just joined, we've done all this from scratch just in the last sort of hour. We've made the enclosure, we've put the plinth on, we've put a little door lock on. Again, I'll reiterate, I would probably never use that door lock for a panel of this size. I'd always want a handle for a panel like this. Let's hide the door. We've got an aluminium glam plate in the bottom. We're going to make this a bottom entry panel, so all the cables will come in at the bottom. And then we've got our trunking and DIN rail in sections. And then we're going to start to put parts on. Yeah, that's my problem. I want to be good at something straight away. Yeah, I feel you with that, Jack. I'm similar myself. I don't have the patience, or not often, to sit and just learn something and just keep using it and using it. But because I use this as part of work, it was kind of it was just natural progression from the 2D stuff that we used to do to moving into the 3D side. Thy will be done. Thank you for the follow, mate. Really appreciate that. And also, thank you for the Thunder Hammer. I missed that. And also, Peter, thank you for the Go Popular. I'm sorry I'm missing all these gifts. I really appreciate it, guys. Thank you. Okay, so one thing I want to do, or I want to show you, is sometimes when I've got a panel like this, and there's not a great deal of space. I mean, there's a reasonable amount of space in this one, but if you've not got a lot of space for incoming cables, it's quite a good idea to put your DIN rail and all your terminals on like a 45-degree bracket. It also makes wiring easier on site. So let's do that. Let's make a bracket. So let's just hide everything that we don't need. In fact, we'll just isolate the mounting plate itself. No, we'll go back one. I want to keep that so I know what space. I've done it again. I want to keep that so I know what space I've got to work with. So for a bracket then, what view shall we go in? Let's go in the left view so I can see it side on. Use a polyline now, and a polyline's a line that doesn't end until you tell it to. It's like a continuous line, but you can take different angles. So I want to make this, let's say 2mm, or it can be, you know, like a galv bracket. The base can be maybe like, let's say 50. That looks okay. How do I want to do this? Let's go up 40. But then we want a 45-degree angle. Now, it doesn't look like I've got my angles on. Just a second. There we go. We should have a 45-degree angle now. Let's make this 50. Then it's 2mm thick. And I did 40, so that'd be 38, I think. No, wrong. 48. Yeah, because that's 50. Okay. That doesn't look right. We'll fix that in a minute. It looks too thick to me. 38, and then I can press C to complete. But this bit here is too thick. So what we'll do is, got a line there. Offset that line by 2mm. Oh, offset 2mm, and we'll do a stretch on that. I wonder if that'll work. This might not work actually. No, it doesn't really work. What's the best way of doing this? Because it's, you probably can't see, but it's pulling in the right hand side up. Hang on. There's probably a better way of doing this. This is because I messed up when I did the polyline. Do you think the software helps? Are some more difficult to use? Definitely. I found Blender to be crazy difficult to get my head around. So this is AutoCAD, but Blender, which is probably what you would use, I imagine, for 3D printing, or maybe Fusion or something. I found Blender to be quite difficult to get my head into. Definitely worth a look. The company's Ace Automation. Yeah, I will. I'll have a look into them, mate. Yeah, I appreciate you letting me know about them. MN, thank you for the follow. Really appreciate that. Okay, so let me get this right. It probably looks a bit weird. I'm just chucking lines everywhere, but I'm trying to keep the thickness consistent. So I want that there. I want that there. There we go. So now, oh, I didn't mean to do that. The entirety of that bracket is now 2 millimeters thick. And now I can extrude it, do a press pull. Can make it, I don't know, say 30 mil wide. And chuck a hole in the center. Maybe 6 mil. No, 5 mil. Let's do 5 mil. How thick did I make this? 30, so that'll be 50. Oh no, hang on. I must have done it 20, did I? Best way to do this, go into front view. And just pull it out of the way a second, pull it down. It'll all make sense what I'm doing in a minute. I want that. So the width is 30, I want it 15. And that's going to put a hole on it. So, and I also want it to be in the center there. That wants to go up by, I think I made it 50, so 25. Oh, it's gone weird again. Hang on, I'm losing my bearings here with this. That wants to be in the center. So now it's in the center. I want it to go up 25. I think I need to be in a different plane. That's where I'm going wrong. Yeah, I need to be in a different plane. Wait a second. It's difficult when you start getting into angles. So look at it from the front. Find where I select the plane. I believe it's this one. No, not that one. Face. That face is now going to be my reference plane. Let's make this 5 mil hole again. And now I should be able to shift it in the Y direction to that point there. There we go, that's better. It's on it now. Because it's on an angle, it makes it a little bit awkward, but you just need to change the plane you're working in. Engineer Kong, thank you, mate. Really appreciate that. Is there any design regs for PLCs like BS7671 for electrical installations? There are standards for control panels. 60204 or 60402. I always get the numbers mixed up. It's one of them two. That's the standard for rotating machinery, I think. Is it that? You'd have to have a Google. I can never remember the numbers. The other one is 60204 or 60402, and the other one is. There are standards. They're not the same as BS7671. They're not like regs. They're standards. The other number escapes me at the minute. Sorry, app crashed. Wasn't sure if you answered. I did answer. Yeah, I basically said the different softwares have different difficulties. I found Blender to be much more difficult to use than this software. So there's my hole for that. And that's where the DIN rail is going to sit on. 61439, that's the one, David. That's the one, mate. 61439, which is for LV switchgear and controls. And there's 60204, I think, or 60402. One of them numbers. But yeah, 61439 is the standard for control panels and LV switchgear. There's numerous standards, but there is, unless, you know, none come to mind, there's no regs other than the 7671, but it doesn't really, I won't say it doesn't apply to control panels, it's just heavily, control panels are just not, you know, not even similar, so it's difficult to try and gauge a relation between them. I don't know if that makes sense. 6024, yeah. It's the 2 and the 4, I always get them mixed up. They're the 2 that I tend to work to anyway. Harry B, thank you for the follow, mate. Really appreciate it, buddy. Right. Let's bring that up. So now I can just fire a load of them across. Say 200, 400, 600. Put them in the center. Probably want mid between 2 points, and then put that on the x-axis there. Right there, now perfectly there. Bring everything back. Yeah, thank you for that, by the way, David. That number just, yeah, they all escape me. They were just random numbers that don't mean a lot, and you only look at them, you know, once every month or once every couple of months or something. It's not something that's at the forefront of my brain. Right, so let's isolate them. We are getting there. I'm going to start putting components in shortly. We'll try and do a better job than we did last week. I didn't have any fuses or MCBs or anything. I was just making it up, but I'll be making it up today. I'll try and remember some more important stuff this time. 45. It actually wants to be 90 then. 118 now. The thing with AutoCAD, it's always a bit of a pain to know whether you need to do minus 45 or plus 45. Alright, so there we go. That's in the right angle. Do you see what I'm doing now? It's not quite long enough, so let's make it a little bit longer. In fact, yeah, no, it isn't quite long enough. So to make it longer, I'll just copy it across, join the two where I need them, do a union to join them two. Although, that being said, I joined them in a bad place because that wants to be over there. Union now. If anyone's not following, just let me know. I feel like I'm just bumbling through it and no one's really, no one's understanding what I'm doing. So I would probably take it to about there, and then we can slice off about here. Let's just do that. Slice that object. Gia Ann, thank you for the follow. Really appreciate that. There we go. It's not quite symmetrical, that is it? There we go. The holes don't quite line up, but in reality you would just ever so slightly move that so it did line up. Hopefully you guys can see all this yet. There we go. So there's our terminal, what's going to be our terminal rail on some angled brackets, and that's going to aid in installation, you know, site wiring of these field cables. I love this, bro. Just going along with flow. Appreciate that, Jack. Thank you for saying that, mate. Google DIN rail. I maybe missed something. Oh, what's the DIN rail for? What are we modeling? This is a control panel, buddy. So we're going to be putting some components on now. Smashing it. Thank you, mate. Medi, Good evening, mate. How are you? Okay, so let's... I tend to always hide the enclosure. You know, the enclosure's there, but you don't need to see it when you're messing... You know, when you're starting to put components on and stuff like that. Appreciate the follow, Medi. Thank you. Okay, so... let's start chucking some components on. I'm going to start this time with some protection. No copper bar in the bottom for shielded cables. I haven't shown an earth bar. I guess let's do it. If you're saying it, let's just do it. So earth bar, I'll go into left view. Earth bar doesn't really ever have to be very big, so let's do... this is probably overkill, but let's do 5mm wide by 25mm high. And let's extrude that. Press pull. And make it not 800. Let's make it 700. Okay. Let's change the color so we know it's copper. I can't see my button. Just a second. Properties, and we'll make it a color of copper. That's a dirty copper, I guess. It's been out in the oxygen for a while. Sunny, thank you for the follow, mate. Really appreciate it. Let's just chuck that on here, that edge, just to sort of gauge it. I can get rid of that rectangle now. Yeah, that copper's way too big for this panel. You don't need very big copper for an earth bar. Not on a control panel anyway. Hang on, I'm in the wrong plane here. I see, I've drawn many of those enclosures as well. You're using AutoCAD 3D instead of Inventor. I am, mate. Yeah. We don't use Inventor at work. We do everything in AutoCAD. So it's AutoCAD electrical. So we do the schematics in it, and then we do the 3D modeling in it as well. Okay, let's bring that up a little bit. It doesn't really have to be critical where this goes. Let's bring it out by 20mm. And let's just make a couple of bolts to go through. Let's do M8. An 8mm bolt. Press pull. Make that 25 or something. I actually want the top side of that to go there. It's not quite long enough, so let's bring it out by 5, press pull it by 15, and put it back in by 5. So you'd sit this on some studs or something, so it's attached to the back plate. Do you use PC schematic? No, mate, I'm not entirely sure what that is. I use AutoCAD. If anyone's got any questions, just ask away. There we go. So that's that one there. Bring that in by... I can't remember how much we brought the other one in by. Did we do anything? Just for the sake of completeness, I'll put an actual dimension against it. So let's bring it in by 20mm. I did the other one by 10. So let's do another 10. So there's 20mm each side. And you would normally punch a whole boatload of holes in it as well. So let's do that. Let's do diameter. Let's make the hole 6mm. They want to start about 50 in. I will array this so that I don't have to individually copy each one. Let's make, I don't know, 20 holes with a distance of 50, let's say 20 between them. And we can do a few more then. We can do 30 will do. Let's say 30 holes. Had to delete all the Autodesk installed programs on Friday as it was saying I had nearly 230 gigabyte. Wow, that's a lot. What softwares do you have, David? I'll be spending Monday reinstalling. Why was it 230 gigabyte? PC schematic is awesome. You can design everything in Excel. Really? I've never heard of that. Paulino. Good evening. How are you, my friend? Prefer Inventor, but I do get using one program for consistent workflow across departments. Yeah, I mean, I guess if I had the choice, I probably would choose Inventor. It's made for 3D modeling. You know, it does it very well. It's designed from the ground up to do 3D modeling. AutoCAD isn't. But no, it does. It works for us. I do like it. Right, let me get this mid between 2 points. There and there, and we're going to shift this on the x-axis to the center. I want to put my snap on. There we go. So now I just need to punch all them holes. So let's punch through. Normally I wouldn't go to like great lengths of detail like this. Maybe I would. I don't know. I have done jobs where I have, but more often than not, you don't need to go too crazy with the model. Well, I mean, if you've got skilled guys on the shop floor, you don't. If you know you don't have skilled guys on the shop floor, they don't have the knowledge, you know, of punching holes like these, then maybe you would have to. Right. What I could have done, rather than punch each individual hole, I could have just brought the whole thing forward and then pulled the back in. I don't know if that makes sense, but user 646, thank you for sharing the live. Santolis, thank you for sharing the live. In fact, thank you for following the live. Really appreciate it, mate. Okay, so there's excuse me. There's our earth bar. There's our terminal rail. Let's start chucking components in. So just for anyone new who's just joined, we have made the enclosure all from scratch in this live. I'd have put a little door handle on. I wouldn't normally do it like that. I would have like an actual handle, but I don't have that model on my computer at the moment, and I don't want to download it. So open the door up, or at least hide the door, and we're doing the internals at the minute. Alex Cordell, I think. Thank you for the follow, mate. Really appreciate that. Are there any particular panels you find difficult to draw, like Form 4 panels? Not particularly. I wouldn't say they're difficult. They just take longer because you've got to do all the sections and stuff. Yeah, I wouldn't say they're difficult. The difficult ones are the funny shaped ones, or the ones sloped roofs. Sloped roofs are pretty hard to. They take a little bit of doing to put a sloped roof on. They're a bit like, I don't know if you were here when I made these brackets. When you're working with angles, you have to get the plane right that you're working in. It's a bit of a nightmare. What's your favourite enclosure manufacturer? Either Schneider or Eldon. For floor standing panels, I always use Eldon. For wall mount panels, I always use Schneider. Kaka, I think it says, or Gagaga, I'm not sure. Thank you for the follow, mate. Really appreciate that. Zach, thank you for the follow. Really, really appreciate it. Is it possible to draw from 3B and 4 on ePlan? I don't use ePlan, buddy. I'm not sure. Yeah, I don't use ePlan. Alright, so let's hide all that. We don't need to worry about any of that now. We don't even need the trunking at this point either. Let's just hide that. We'll get rid of anything that's just visually in the way. We don't need the earth bar either. So we'll just hide all that. We're left with the DIN rail. Let's start chucking some components on. I'll start with maybe some circuit breakers, I think. Just finding the folders. Now then, I don't have any of those. Let's go for Schneider. MCBs. Let's chuck some actinines on. Maybe a mixture of 1 pole, 2 pole, and 3 pole. Let's go for that, I think. Let's bring this in. So I don't think there's any colour on these. There isn't. I have actually made some ones with colour on for work. But just for now, these will do. So there's a single pole MCB. And we're just going to attach it to the DIN rail. Let's do an array. So there's only 1 row. I think are they 18 between MCBs? 18 gap between them, but let's do 18 and a half. And let's say there's, I don't know, 10 of these. I don't like the fact there's no colour. I like to have colour in my models. Probably isn't an easy way of me of, yeah. We'll live with it for now. Let's bring some 2 poles in. There is no real design to this. That I haven't done any circuits or anything like that, so we're just kind of making it up on the fly. Any books, programs or courses you recommend to better understanding of PLC programming? Yes, you might have come from the video that I did about it. I did a video maybe 2 or 3 weeks ago with exactly what you're asking. But I'll say it again anyway. So Paul Lin is a good course on plcdojo.com. He has some really good courses on Alan Bradley stuff. There's a guy called Shane Welcher on YouTube. He has some good stuff. He also does courses. I've not tried his courses. paulinplc.com. It's PLC Dojo, I think, isn't it? Yeah, he has some good courses. As for books, Frank Petrozzella is the author of a particular book. I can't remember the title of the book. It's probably just PLC programming or something. Yeah, he has a pretty good book. Who else? William Bolton. He has a couple of good books. Some on mechatronics, some on PLCs, and maybe there's one on general control systems as well, I think. Yeah, have a look into them. Also a book by a guy called Liam B. He does about Siemens PLCs. Pretty good stuff. Let's make that 37 so there's a bit of a gap. What else did you ask? That's about it really. Yeah, courses and programs. There's tons of stuff on YouTube. Guy called Hegemerl. He's a German guy. He does Siemens PLCs. He hadn't made a video for 4 years until about 3 days ago, and he's saying he's back now, which I'm happy about because he's a really good teacher. That was too far. Let's make that 10. Right, so I've got some 1 pole MCBs. I've got some 2 pole MCBs. Let's do a couple of 3 pole and call it done with the MCBs. Up here. I make panels for food, pharma, EPC projects. So my go-to is Rittal. Yeah, I know a lot of people use Rittal. I guess it's just historical. I've never really used Rittal. None of the guys I've ever worked with used Rittal. But I do know they're one of the biggest, if not the biggest, enclosure manufacturers. Yeah, they've got funny part numbers and stuff. They probably do make sense. There's probably a rhyme and reason to it. But yeah, I just don't use them, to be fair. I'm having to rebuild an unlabeled panel with 10-year outdated drawings made of cables loose. Yeah, it gets like that, doesn't it? Retrofitting panels can be a nightmare, a real nightmare. Especially if the drawings are old and out of date, you're having to guess stuff. Well, the only real thing you can do is just go and do a site visit and just start tracing wires out and stuff like that. Yeah, it's never easy, but that's why you get paid the big bucks. Watch Hegemerl on YouTube, great starting place. Yeah, agree. Hegemerl's great. Industrial and solar manufacturer, thank you for the follow, really appreciate that. Okay, so we're now pretty much done with the MCBs. Let's just have that for the MCB rail. Maybe center him a little bit better. Okay. Now let's put in I've got a lot of sections going on there. What else should we add? Let's add some manual motor starters. Have I got any models of those? Motor starters. Ah, these are one of these big Schneider ones. I'll chuck one of these in. I think I've got all the parts. So these are really, really solid motor starters, these ones. It's a Schneider. I think that's the lub, is the base, is a lub. Then we get a Luca, which is the LUCA, which is the the clever, intelligent bit. That's not coming in where I want it. I'm gonna have to put these together. It might even be in the right place. Is that where it sits? Let me bring up a picture of one. I ain't seen one for a little while. Schneider Luca 12, I think. Bacon, welcome back, buddy. In your opinion, what's good program for making panel drawings? I mean, I've only ever really used AutoCAD Electrical. We used to use just generic AutoCAD, but that was a nightmare. AutoCAD Electrical is what I use. I do understand it is expensive, so it's not really an option for everyone. I've heard a lot of good things about SkyCAD. I've heard some good things about FreeCAD. E-Plan seems to be the way everyone's going, but again, I think that's pretty pricey. I think it's pretty expensive. It goes to the top slot. Yeah, I'm just looking at some pictures now. I've not used one for a good while. I was going to get the instruction sheet up. Normally, that's what I do. If I'm not sure how it goes together, I'll look at the instruction sheet and see. It just goes in the center by the looks of it. It's kind of not showing where it goes. Like it goes in here by the looks of it. E-Plan is meh. Yeah, I've not used it, but a lot of people go into it. A lot of people are using it, so I can only assume it is okay. Do you actually draw cabinets in 3D? Yeah, I mean, we at the start of the life we drew the cabinet. So there's there's a custom enclosure. If I on a standard job, I'd probably just import an Eldon or a Schneider panel or something, but I do quite often get customers who want a custom enclosure, custom size, custom color. They don't want just the off-the-shelf enclosure. They want it to look different to everyone else's, so they get something custom made, and I draw it up, and then we send it off to a fabricator. Yeah. Shaper 3D. I've not heard of that one, Lee. Yeah. Is it any good? E-Plan crazy. In what way, Faye? I think Fell, maybe? I am the cabinet stripper. As in that, old cabinets, you go in and strip out all the stuff, or? But E-Plan can don perfect material export. I'm not sure what you mean by that. Engineering base is interesting. I'm not sure what you mean by that either. Maybe I'm missing some comments. FreeCAD is usable, but it's a one-off or occasional thing, but AutoCAD would be recommended. Yeah, AutoCAD Electrical is good. I've heard SolidWorks Electrical is okay, but I've never used it. I don't know if anyone's used Zuken E3. I absolutely hated that. I think that is a terrible software, but some people love it, so yeah. A HD mechanic here and work with PLCs. What should I do to get into the programming side? Download some free softwares, have a practice. If you ever get the opportunity to look at someone else's programs, study it, see how they did certain things. Practice. Maybe do a course. There's some good courses out there. Figured I'd start offering updated drawings for Oh, hang on. I've lost your comment there. Figured I'd start offering updated drawings for Franken cabinets as a service. You're probably onto a good thing there, Bacon. Yeah, you probably could, because there's so many sites out there that just don't have drawings for their own equipment. It's crazy. I think that goes somewhere in there. It does. It does. So there we go. I'm starting to build it up. There's no colour to these drawings though, these models, so I don't like that. I like to see colour. I think it looks so much better. There's one more part to add. Bobo, thank you for the follow, mate. Really appreciate that. What software is this? This is AutoCAD Electrical, buddy. We always draw the line with cabinets, never the inside in 3D. Ah, see, okay. Yeah. That's how I used to do it. I used to do 2Ds. And then I sort of moved on, leveled up a little bit into 3D. Oh, engineering base is a software solution. Ah, okay. I have these motor starters. These motor starters are good. Yeah, they're really good. If you get the clever ones, they have Modbus on them, and you can pull out the motor current, motor voltage. You can control them, remotely over communications. Yeah, they're great. I really like them. They're just a little bit. They're a little bit big though. That's the only problem with them. They're a bit tall. This goes down at the bottom, by the looks of it. It's not lined up perfectly, but it's not too bad. It's because that the edge is filleted, whereas this thing's got a proper corner, so it's never really going to go on right. Let's just look at it from a front view, and I'll do it by eye. Doesn't have to be perfect. It's just visual. That looks good to me. Okay. So once I've built that together, I don't want to be doing that every time. So I'll group it together, so now it acts as one block. So if I move, the base, it's not going to move everything. It's not going to leave everything else where it is. Okay, so apparently it comes in with its own DIN rail as well. Probably makes it easier for me. I'll just snap the DIN rail to my DIN rail. So there's going to be a bit of clipping going on there, but it's fine. I need to remove my door. In fact, I'll remove all the enclosure because it just gets in the way. There's no need for it. I don't even need the back plate. I've missed a load of comments. I'm probably not going to be able to see them all. FPGA versus PLC. Well, an FPGA is, a single device on its own with no real I/O, no communications as such. It's just a chip. You would need a load of circuitry around it to make it useful. So PLC for me every time. That's the benefit of a PLC. It's got everything you need to automate something built in. It's robust. It's been tested to a high standard. It's probably going to last you 20, 25 years, maybe more, 30, 40 possibly. Yeah, there's no substitute for a PLC in industrial automation, in my opinion. Not even these, I don't know if anyone's seen them, the, what are they called? Industrial IPCs? I think it's industrial PCs that run like a software PLC on them. They're becoming more and more of a thing. I'm not fully convinced by them myself, but time will tell. It does seem to be the way a lot of companies are going, using those. Let's chuck, 10 of those in. Let's make the space 50. That looks not too bad. So there's an absolute shed of motor starters. Logic controllers on site, slowly getting into the AB PLCs. Ah, okay. What sort of site do you work on, Bacon? What sort of work do you do? Was it manufacturing, or was that someone else who said that? Nice drawing though. Wish we'd pay for it here. They're real nice. I use them a lot. Oh, I see. So you use FPGAs a lot or PLCs? Well, you can upgrade to DCS from PLC, but costly. Yeah, you know, you're right. It is, but not DCS doesn't really work for small sites either. You know, you wouldn't control a machine with a DCS. That's what the PLC's for. DCS is like a stack of PLCs that all come back to one central place. Natural gas compression facilities. Ah, okay. See. Yeah. AB as in Alan Bradley, Rockwell stuff. They're pretty big out in the oil and gas. As is Siemens. Yeah. Software PLCs are real nice. I see DCS disappearing more and more. Yeah, I'm not convinced by the software PLC. I'll be honest. I'm not entirely sure they're going to be as robust as a proper PLC. But they're becoming more and more of a thing. So maybe there's some merits to them. Processing plants and larger stations run PLCs. Most units using logic controllers, like Murphy, Altronic. Yeah. Thing of a Wolf PLC as a Linux device. You've got a face as a name. Thank you for the follow. Really appreciate it. They run forever. Thing of a Wolf. What do you mean by that, Snex? Okay, so there's our starters. Let's add some more components so we're not having everyone just sat watching a static screen. Let's go back. What else should we add? Let's put a controller in. Let's put a PLC in. What PLCs have we got? I've got a load of parts for an M340 PLC, a Schneider one. So let's maybe chuck that in. Do I have... There's a processor. I hope it's not all white. All these Schneider parts seem to be all white. It is. Do I have anything with a bit of colour in? Because I don't like the white. Have I got any other PLCs in here? Thank you, user422, for saying that. Right, what PLCs have I got? I've got some Alan Bradley in here. 1769 control logics. L35E processor. Does that have colour in it? That's what I want to know. No, it's white. Why are they all white? I don't want to use white stuff. I must have something with a bit of colour in it. What about my... I bet even the Mitzi ones. I feel like the Mitzi ones are even not coloured. Yeah. Alright, well, let's go back to... Let's stick the Alan Bradley in. The 1769 control logics. Let's go back. Alan Bradley. 1769. L35E. I think these are an old processor that I don't think they... I don't think they're supported anymore. They're not supplied anymore. I think they've moved on to... Is it an L33ER or something? Is like the equivalent, maybe. Can you just add the colour? I can, but it's a bit of a pain, and it does take a little while to add colour. So when I come across parts that are just all white, if I'm doing it for work, I'll probably just spend that 10-20 minutes colouring it all in. Because once you've done it once, you kind of just copy and paste that going forward. You do the work once and you just keep reusing it and it looks better. But for this, I'm not going to bother for this stream, but let's just start chucking some IO on stuff. And see, that's a funny colour, isn't it? That is a strange colour. And is that upside down? I think it's upside down. So So, where is the mating points between these two? I would say it's probably here. And stick that onto this rail here. Oh, hang on a second. I think my software's having a moment. What have I missed out on? ABB is a terrible one-way route. Oh, my software's crashed by the looks of it. We might be ending the stream short. This software's AutoCAD electrical, mate. I don't know what's going on with my software at the moment. But ABB is 100% convenient, of course. I've obviously missed some comments, I'm sure. Automation expert from Schneider. I've not used that one. That one's a new one. I remember when I got some training for some Schneider PLCs, and the guy who was training us was saying, here we go. Was telling us how this software was the future or something, because it basically allowed that software could program a number of different manufacturers' PLCs or something like that. He seemed to think it was the best thing since sliced bread. I haven't used that one yet though. I'm not entirely sure what PLCs you use it on. This isn't picking up at all, is it? I think it's the model. I'm gonna change tactics, so I'm not gonna use the Alan Bradley stuff. Let me just purge that, because those blocks are in there, in the drawing. Let's get rid of them. Let's use a different PLC then. Let's go back to the Schneider, I think. Seemed to be my computer didn't seem to like the Alan Bradley model. And let's keep it simple. Let's use an M221, because I do know exactly how they fit together. I've got a bunch of them without having to look up data sheets. 90, another 98. There we go. There's the front of it. It's funny how all the Schneider models are white. I'm not sure if I've ever actually noticed that before. Let's add a couple of expansion modules, and they've come in pink for absolutely no reason. User 727, thank you for the follow. Isaka, thank you for the follow. Really appreciate it. So this mating point is those little bits in here. If I mate that with that, there we go. Let's have a couple of those. Let's have, say, 3 of them. It's a bit too close, I think. So 20 through 24. That looks good. Have I got any other models for that Schneider PLC? Let's stick one of them in. So all we're doing now is just build the PLC up, and we can chuck that in. I don't know why those models are pink. Some models come in really weird. I don't know if it's how they're drawn or what. But now I've done that, I'll group that together. Take the door off my panel. In fact, take the enclosure off altogether. Don't need that. Oh, I'm losing it here. If anyone's got any questions, just ask away. There we go. Right, so there's a controller in. What else? I'd probably actually, in reality, put that controller on the next in-rail down. There we go. Let's chuck a load of relays in. I should have a drawing with a load of relays. Oh, there's some conversations going on. You're building a new factory the upcoming 10 years. Oh, so the next 10 years, that's your work, building a factory, is it? Not that drive. I want this drive. Documents. Parts. I use on-run relays, so I'll chuck a few of them in. I'll just open that drawing up, put it in shaded with edges. The colours aren't quite right in that. I've got a load of... So on my computer at home, I've got just a stack of old parts. I've actually... A lot of this stuff that we're seeing, I've already coloured in. I just don't have them on my computer at home. Let's put the relays... Let's put them down here. So there's a relay. Let's do the same thing again. Array. Let's make 30 of these. 18 between them. There we go. So there's a stack of relays. Apps you using, bro? This is AutoCAD Electrical, mate. What's the software? Oh yeah, AutoCAD Electrical. Lee, thank you for saying that, buddy. By the way, start learning 81346 now. What's 81346? I'm not sure what that is, buddy. Okay, so what else can I add in? I've got. Let's add some terminals. I should have a model for. So I like to use Entralect terminals. They're the kind of brand that I tend to stick to. Where's my folder for them? And I sort of standardise on these terminals, which are the M4 to 6 terminals. They're a 4mm terminal, screw terminal. 90, 180. So let's bring that down. Andre Barto. Thank you for the follow, buddy. Really appreciate that. It's 45. I think it's minus 45. There we go. Okay, so there is my grip point. Put that on there. No, that's not quite right. I want it to go on the bottom side. There we go. So there's a terminal and same sort of thing. Let's make 25. One row. And I think there's 6mm between them. So there's a block. Let's bring in some end stops. If I put them somewhere. End stop. Let's bring that in. Oh, I've got an itchy nose. Weidmuller for you. Yeah, that's fair enough. Yeah, Weidmuller are pretty decent. My old company used to use Weidmuller. Minus 45. This one's not got as nice grip points. I'm going to take that one there to the bottom side of there. And again, everything's coming in grey. I should have just copied a load of parts out of a previous drawing where everything has colour in it. But it is what it is. There's actually an end plate as well to go on, which I haven't brought in. I forget the part number of it. I think it's this one. So terminals often come with just one side exposed. So you need to put an end cap on, like an end plate, to cover up that exposed terminal. Minus 45. I think that doesn't look right. I think I need to go the other way. Let's go 90 degrees. That looks better. IEC 81346, International Standard for Designation. Oh, okay. Wago have nice concepts. With 81346, you designate every object in your drawing, including cables. Yeah, I mean, I would. All our panels have wire numbers in. Every component has a like a circuit reference. What wouldn't have? We say every object. You mean like down to DIN rail, trunking? We wouldn't label those. Okay, I'll have a look. Yeah, I'll have a look. Sova, thank you for the sharing the live. Thank you, really appreciate that, man. So I think it's Sova. Yeah. Let's move that 2 mil across. Right, there's one block of terminals. Let's just do the same again over here. Let's have, I don't know, 50 of those. And then that just shifts over by about there. The colour's distracting me. I don't like the no colour. The fact that everything's white displeases me. That'll do for terminals. I don't want to go too crazy, but if we bring the panel back, the enclosure itself, you can see why I built the brackets. So if you're on site, you're on your hands and knees wiring these field cables. If that terminal's facing you, rather than facing 90 degrees, it's so much easier. It's so much easier for you to put wires in when you can actually see the bottom of the terminal and that sort of thing. Yeah, so I try to use the 45-degree angles where I can. It just makes life easier for the guys on site. It also means you can get away with this. So if you didn't have much space, if I move all these terminals down a bit, it means you get it makes it life easier. If you've not got a lot of space, if those terminals, let me go into X-ray mode so that's not in the way. If those terminals were sat on the back plate, it would be very difficult to terminate them on site. So having the 45-degree angle brackets makes life a lot easier. Thank you, Snex. I appreciate you telling people that. Most of my daily work is writing standards and harmonizing them. Oh, is it? Oh, okay, that's interesting. Whereabouts are you from, Snex? What country do you come from? Sweden. Ah, okay, mate. Yeah, okay. We use a lot of Bayer HMIs. I don't know if you use those. I believe they're a Swedish company. It's the only real company I can think from Sweden that I might use. But you work internationally a lot. Oh, okay. Right, so there's obviously 2 sections that I've not populated, but I'm kind of running out of time now. I feel like I've showed enough for you to understand kind of how to build 3D models in this software. So if you have AutoCAD and you haven't done any 3D modeling, hopefully that does help. Gives you an idea of what's involved and my thought process in when I'm doing this. I could bring that back up. That looks rubbish on the bottom. What I'm thinking is maybe for my next stream is maybe do a circuit to go along with it. I don't know, we'll see. We'll see what happens. My idea ultimately is, I don't know if Bacon's still in here, but I missed that you'd sent some gifts. Thank you for that. I really appreciate it. Yeah, the idea, I think I'm gonna come up with a project where I build the circuit, I 3D model the panel, and then I program the PLC. I think that's what I'm going to be doing on my next lives. I also didn't put anything on the door yet, so maybe that I have to wait till the next live. But my throat's starting to give out. I've been doing a lot of talking, and I'm probably going to end it there, guys. I appreciate everyone who's liked the live, who shared the live, who's gifted tonight. It's really, really appreciated. But yeah, that's 3D modeling in AutoCAD. So I'm probably going to call it there. Yeah, thank you to everyone for joining. Thank you to everyone commenting, joining the conversation. I'm going to save this drawing and I might come back to it on another live. And we'll finish it off. Because there's a couple of sections I haven't finished off. And also the colours, maybe I'll sort them out off stream. Yeah, so thank you to everyone for joining and all that good stuff. I will see you on the next live.